Bill here. I hope you've enjoyed making your RoboPot. If you're interested in learning more about the computer science involved in making that RoboPot work, let's step into the kitchen and make some oatmeal. As I make my oatmeal, I'm going to play the role of a computer, and the first thing I'm going to need is a set of instructions. I'm going to get my instructions on the side of this box. They call it a recipe, but in computer science we call it an algorithm. My first instruction is to put 3 cups of water in a pot. For this I'm going to need the second thing that computers have, which is memory. And I'm going to start by remembering that I haven't put any cups of water in, so that's 0. Now I remember that it's 1. I remember that it's 2. And 3. I've followed the instructions to bring the water to a boil, and the next instruction is to add the oatmeal. So by following the instructions of my algorithm and using my memory, I've been able to make some tasty oatmeal. We'll talk about how all this applies to your RoboPot computer in just a minute. For now, let's do an activity with a pretend computer. This is our activity sheet, and what we're going to discover through this activity is which of these flowers gets watered when the pretend computer turns on the hose. On the left side of the activity sheet, we see the pretend computer's instructions and the pretend computer's memory. I think the best way to get started with this is for me to just show you how it works. The first instruction just tells us to set x and y to 0. So I'm going to go over here to the memory column and just write a 0 under the x and under the y. Next, the pretend computer wants to draw a drop at x and y. Well, x and y are just 0. So I come over here to the graph and I find the box where the x coordinate is 0 and the y coordinate is 0, and I draw a drop in it. Next, it says to set the new y to the old y plus 5. Well, the old y is 0, so adding 5, I get 5. I write a 5 in my memory column and under the y, and move on. Next instruction says that the new y is the old y minus the old x. Well, the old y is 5, the old x is 0, and when I subtract 0 from 5, I just get 5, and I write that down again in my memory column under the y. Here's the part where we change x. From now on, just before we're getting ready to draw a drop, we're going to increase x by 1 so that the drops move from left to right across the field. Now we come to another drop drawing instruction, and this time the x and the y. X is 1 and y is 5. So I'm going to find that box where x is 1 and y is 5, and I'm going to draw a drop in it. And now we come to a whole new shape. This is a diamond. The diamond represents the situation where the computer has to make a decision. And the decision is written inside the diamond in the form of a question. The question is y greater than 0? Well, y is 5, and indeed it is greater than 0. So we follow the yes path out of the diamond back up to another instruction. In fact, one we've already done. What we're going to do now is repeat the instructions we've already done over and over again in what's called a loop until finally that diamond question says no, and then we stop. And having done all that, we will have drawn drops on the graph paper in a path that ends up on one of the flowers. Will it be the purple hibiscus, the red poppy, or the yellow rose? Spoiler alert, I'm getting ready to show you the answer. So if you want to figure it out on your own, stop the video. When I followed the algorithm, the water drop ended up on the red poppy. If you've had some algebra, you may notice that the shape of the drops is a parabola. So what we've learned in this activity is that the way that a computer works is it follows instructions that operate on a memory to have some effect in the real world. Now that we've learned something about how a computer thinks, let's explore how our RoboPot computer thinks when it's executing its daily watering algorithm. Now, if you're going to water a plant, what's the first thing you got to do? You got to turn the pump on. So we're going to start with that. And if you don't want to flood the house, The next thing you got to do is turn the pump off. So let's add that in. Now it's not enough just to turn the pump on and off. You want it on for a certain amount of time. So we're going to add this middle box that waits an amount of time set by the dial. By the way, these three boxes are actually a simplification of more complicated things going on under the hood. For example, to turn the pump on, what the computer actually does is change the voltage on an output pin, which then goes through the resistor to that transistor that you put in to turn the pump on. Now for that middle box, let's say something about that dial. The dial sets a voltage that the computer can read and then do some math to turn it into a certain amount of time in seconds, which the computer can wait for. So how does the computer know when to do these three steps? Well, it has to ask itself a question. So what kind of shape do we use when asking a question? We use a diamond shape. And what should the question be? Is it the right time of day to water the plant? And if the answer is yes, we're going to go down and do those steps. If the answer is no, we're just going to go around in a loop and ask the question again until finally, sooner or later, it'll be yes. Finally, after the computer's finished watering the plant, we have to go around to the top again to wait for the next daily watering. Now that we've completed this diagram that a computer programmer would call a flowchart, let's look at the code that corresponds to it. Now the code is a sequence of statements, and the first statement is called pump on, and it just corresponds to turning the pump on. Now the pump on statement is just a way of referring to a bunch of details laid out elsewhere in the program. When we name a collection of details so we can call on it later, we refer to that as a function. The next statement is another function that says dial delay, and its job is to, again, read the dial and wait the amount of time indicated. Then we turn the pump off. Now we have to look at the code that corresponds to that diamond. Remember that the diamond is asking a question, so how do we get the computer to ask the question that's inside the diamond? Well, one of the ways that we get computers to ask questions is by using what's called an if statement. The if statement has three parts: the word if itself, question to ask, and what to do if the answer is yes. What you can see first is the word if and the what to do if the answer is yes, which is enclosed in those curly braces. So what question should the computer ask to figure out if it's time to water the plant? Well, how about, has it been a day since the last time the plant was watered? So how are we going to write some computer code to answer the question, is it time to water the plant? Well, let's look at what the computer has to work with. I've got some file cards here that represent the things that the computer can do. First, we have a digital stopwatch that simply counts time. We have the usual arithmetic operations. We can compare numbers. We also can go look in our memory and see anything we've already stored there. We have a place that we've stored the last time that the plant has been watered, what the stopwatch read at that time, and we have another place that stores 24 hours, a constant. So the question is, how can we put these pieces together to answer the question, is it time to water the plant? Now why don't you take a few minutes and try to arrange these cards in the form of a question. And for the cards that have multiple symbols on them, draw a circle around the symbol you want to use. Here's another spoiler alert. I'm about to give you a hint and then tell you the answer. The first hint is to narrow down the operations you'll be using. We'll be using the minus, and we'll be using the greater than or equal to. The next hint is that you can figure out how long it's been since we last watered the plant by taking the current time and subtracting the last watering time. And the final piece of the puzzle is that once we know how long it's been since the last watering time, we can simply compare that to 24 hours. And if that time is greater than or equal to 24 hours, it must be time to water the plant. Okay, here's what this looks like in code. Our stopwatch is one of those functions we keep talking about, and it's called millis. And the reason it's called that is because the actual stopwatch in this computer counts time in milliseconds, which are thousandths of a second. It's a very accurate stopwatch. The last watering time is just spelled out. It's the name of a memory location that we've defined. You can see the minus sign between the millis and the last watering time, just like we used on the file card. You can see the greater than or equal to sign. And now we just need that 24 hours. We have a memory location defined in our program called hours to wait, and we have to convert that to milliseconds because that's what our stopwatch measures. So we're going to multiply the number of hours by 3,600,000 because that's the number of milliseconds in an hour. So here's the completed code that implements our flowchart for the daily watering section of our RoboPots software. If you've enjoyed that and you want to learn more, the Leader's Guide has the complete flowchart that includes not only the daily watering, but also the portion that does the button. If you're still having fun, the Leader's Guide also has a complete listing of the computer code that runs in your RoboPot. Congratulations. We'll see you on the next adventure.